In this video we are going to explore the first aspect defined in the IEC 61131-3 standard, the software model and program organization units. If you want to know more about the overall scope and history of the standard, check out the previous video of this series. Today we are going to get practical and use CodeSys to visualize these concepts. If you don't have CodeSys installed or don't know how it works, check out my Introduction to CodeSys video series. Links are in the description of this video. The standard provides a hierarchical framework for organizing PLC application code. At the highest level, we have the configuration that encompasses the whole system setup. Below are resources, the actual CPUs that run your code. You might have one or more CPUs in your system. The resource manages tasks. The task is the scheduler. It defines the execution context. It tells the CPU to run a specific piece of code, either cyclically, for example every 20 milliseconds, or based on some event, like an interrupt. The code itself is written inside Program Organization Units, or POUs. The standard defines that every programming unit has two distinct parts: the declaration, where inputs, outputs, and internal variables to a programming unit are defined, and the implementation, where the actual logic code is written. The standard defines three distinct types of program organization units. Choosing the correct one is not a matter of preference, it is a matter of software architecture and memory management. First, we have the program. Programs represent the main executable entities within a PLC application. They are the only program organization unit that can be directly invoked by tasks. Programs can also be called by other programs, and another important thing is that programs have state retention, meaning that their own local variables will retain their values between consecutive executions. This allows programs to manage sequences, accumulate values, or maintain information over time. They actually have memory. A program is unique within the PLC application. You cannot create multiple copies of a program linked to the same code. When you create a program, it is instantiated and can be called by tasks or other programs directly. In the default CodeSys project, a program called PLC PRG is created and is called directly by a cyclically scheduled main task. If you want to add a new program to your PLC application, right-click on Application, select Add Object, and select POU. In the menu popping up, you can select Program and choose a name for your program. You will see a new program appearing in your device's tree, in which you can write your own logic, your own declaration and implementation. Then you can either call this program from another program, or call it from a task in the task configuration. Then we have function blocks. This is the most critical component for modern modular programming. Like programs, function blocks are stateful. Their variables need to be allocated and retained through multiple scan cycles. But unlike programs, function blocks are not meant to be unique. Think of a function block definition as a blueprint. To use it, you must create instances or copies of that blueprint. Each instance will have its own independent set of variables, meaning it will have its own memory and state. Function blocks are the equivalent of classes in traditional object-oriented programming. Through this mechanism, it's possible to use logic to control multiple occurrences of the same kind of object, for example, an asynchronous motor. You can reuse the same code by creating multiple instances of it. In this way, you can achieve modularity and efficient design. Adding a function block to your project in CodeSys is similar to adding a program. Just right-click on Application, select Add Object, POU, and select Function Block. and choose the name of your function block. Then you can write your own logic in it and create one or multiple instances of it and call it in other POUs. Then we have functions. They are the simplest type of POU designed for executing specific reusable algorithms. Functions can be called by programs, function block, or even other functions. Crucially, they have no state retention. They do not possess internal memory that persists within calls. Any variable inside a function is temporary. It is created when called and destroyed when finished. Use this for mathematical calculations, conversion, or for logic that should always return the same result given the same inputs. To add a function to your device's tree, you right-click on Application, select Add Object, POU, and select Function, and choose the name of your function. When you create a function in Codesys, notice this extra field, Return Type. Unlike a program or a function block, a function is meant to return a specific result, like a number or a boolean, directly to the caller. You can write your own logic in your function and call it from whenever you like to run the calculation and return the value that you need. To summarize, use programs to organize the main sections of your machines, use function blocks for devices like motors or timers that need memory, and use functions for pure calculations. Before we move on, let's do a quick reality check on how manufacturers actually implement this standard. For PLC manufacturers that either use Codesys as their IDE or provide their own Codesys version, you can expect the terminology to match exactly what I just described. However, two of the biggest players in the market, Siemens and Rockwell Automation, use their own terminology. Siemens implements the standard quite closely in TIA Portal and CMotion. They support function blocks and functions just like the standard. The main difference is the program. Siemens calls these organization blocks or OBs. Rockwell Automation is the most unique. While they support the concept of the IEC program, the structure is different. In Studio 5000, a program is a container that holds tags and logic, but the actual code is split into multiple objects called routines. For reusable logic, Rockwell uses add-on instructions. They work almost exactly the IEC function blocks, so they have inputs, outputs, and internal memory. However, Rockwell does not provide a direct equivalent to the IEC function. To achieve that behavior in Rockwell, programmers often have to use subroutines or global add-on instruction instances as workarounds. And regardless of this naming difference, the architecture remains the same. If you want to practice declaring these POUs yourself, you can check out my courses on Udemy or my book PLC Programming for Beginners on Amazon. In the next video, we will look at the data model and understand variables, data types, and scope.